Hello everyone, I hope you all are doing good. In today's class, we'll be studying about collision. Now, before we get started, there's a bit of change in the method of note taking for today's class and a few of the upcoming classes. Reason being, my device broke down for a bit, so I had to sort of take my notes for the classes on the pen and paper. So I hope, however, I have tried my level best to keep my writing very clean. So yeah. Moving on to today's topic, collision. Collision is a brief interaction between two bodies due to which interchange of linear momentum and kinetic energy takes place with or without contact. Okay, so collision could be like very simply, as we know, collision is this thing happening. Okay, so this hair tie um, is colliding with this earpods cover, right? It's as simple as that. So what happens during collision is that there is an interaction between two bodies that is happening, due to which there is an interchange of linear momentum, p is equals to mv, and an interchange of kinetic energy, formula half mv square, which takes place with or without contact. Now, in any kind of collision, conservation of linear momentum is valid throughout the collision for the system. So, whatever the type of collision is, however two bodies are colliding or three bodies are colliding, whatever, the for the system of particles during collision, after collision, before collision, the conservation of linear momentum is valid. Linear momentum is always conserved for the system. Now, remember, I keep repeating this, that this linear momentum is conserved for the system. Not, it may or may not be conserved for individual particles that are colliding. It could be conserved or it could not be conserved. But for every type of collision, linear momentum for the system will always be conserved. Okay, so the final momentum would be equals to the initial momentum, right? So the momentum before collision will be equals to the momentum after collision. Is that clear? Now, moving ahead, momentum of individual body may or may not be conserved, as I said earlier. Mechanical energy of the system may or may not be conserved. Okay, so this depends on what type of collision it is. If it is sort of like elastic collision or non-elastic collision, it depends on that. Okay, now types of collision, we will study about head-on collision, right? That's in our syllabus. Now, what happens is that in this, two bodies which are following the same line of motion, they collide with each other, right? And after collision they move their separate ways. Now, let us imagine that we have these two balls right over here, right? One of them is moving with u1 velocity and it has a mass m1. The other one is moving with u2 velocity and has a mass m2, right? And these are moving in the same direction. At some point of time, these two collided. Now, firstly, when they are colliding, what can you what can you go by logically? That u2 must be smaller than u1, or u1 must be greater than u2 for the collision to happen, right? Think about it. Like, the mass m1 is behind mass m2 and they are both moving in the same direction. So for the collision to happen, m1 should be traveling with a greater velocity than m2, right? So now, it isn't significant in this at this point, but I was just trying to connect the dots for you, how you should be thinking when you are solving a question, right? Now, let's say that these two bodies collided, right? So at some point they were together, like when they collided, they are like together, right? And after, what happens is that after collision, they starts moving in a separate way, with the m1 starts moving with v1 and m2 starts moving with v2. When they are colliding, when they have just collided, at that time they have a common velocity which is called vc, and at that time they both the bodies come together and their masses are sort of considered together, right? During collision, the F net on the system is 0. Okay, so during collision, the net force on the system is 0. Because of that, conservation of linear momentum is valid throughout the collision. Okay, Now, kinetic energy is not conserved throughout the collision. Reason being, think about it. Initially, the body was moving with the speed u1, right? And u1 and u2, and later on they start moving with velocity v1 and v2, right? So there's a difference in velocity at these points. So obviously the kinetic energy is different, okay? Now, kinetic energy is not conserved throughout the collision. Also, if you think about this part, what happens is that half m1 half mv1 half mv1 whole square plus half mv2 whole square maybe the initial kinetic energy and the final kinetic energy would still be similar, but the kinetic energy at this point during collision is like it sort of decreases. Why? Because when two bodies were moving right before collision, they were moving with some initial velocity, so obviously they had some kinetic energy, right? After collision also they were moving separately, so and they had a velocity v1 and v2, so again they have some kinetic energy, right? But during collision what happens is that they come together and then they are moving with a common velocity vc, right? During collision what happens is that some of the kinetic energy is used by the system to sort of like, it is stored, like, okay, and used by the system as the energy for deformation. What happens is that when these two bodies are colliding, there is some deformation that is occurring in their shapes, okay? These two solids are like very rigid, so we are not able to tell apart that deformation in like with our naked eyes, but that deformation occurs. To be able to like imagine that deformation, think about it like when you have two squishy balls, right? Two sponge balls, and you like make them collide together, you will see that okay, their shape deforms, right? And then after some time when you like sort of pull them apart, their shape gets back to normal, right? What happens is that their kinetic energy is converted into energy for deformation at that time during collision, okay? So during collision their energy, the kinetic energy is converted into the energy of deformation. Hence kinetic energy is not conserved throughout the collision. Kinetic energy like could be the same initially and finally depending on the type of collision, but kinetic energy is not conserved throughout the collision. During the collision some of the kinetic energy is lost in the form of what? In the form of energy of deformation, okay? I hope that is very clear. Let's move on. So during the collision, some part of kinetic energy of the system is stored in the form of elastic potential energy of deformation, okay? So that energy, some kinetic energy during collision is converted and stored into elastic potential energy of deformation that causes the deformation in the shape of the body. Now, based on how much deformation is there and whether this energy is given back or kept going forward, we define the different type of collision. If all of the stored elastic potential energy of deformation is given back to the system, then the collision is said to be elastic collision. So what happens is that before collision the body was moving with some initial velocity, so it had some kinetic energy, right? And during collision some of that kinetic energy is stored in the form of elastic potential energy for deformation and used to, right? But after collision the bodies get separated, right? So they regain their shape, so there's no need for that energy of deformation to be stored, right? So what happens is that if after collision all of that stored elastic potential energy for deformation, if all of that is given back to the system in the form of kinetic energy, then think about it, then the initial kinetic energy will become final kinetic energy, right? Because what is electrostatic potential energy of deformation? It is the initial kinetic energy minus of some energy, right? So what was the final kinetic energy? If the electrostatic potential energy was not let's say given back, or let's say during the collision, what will be the kinetic energy of the system during the collision? It would be the initial kinetic energy minus of the stored elastic potential energy of deformation, right? That would be the kinetic energy of the body during the collision. After the collision, if this stored elastic potential energy of deformation gets converted back into what was taken from the kinetic energy, then the final kinetic energy will become the same as the initial kinetic energy, right? This type of collision, where all of the stored elastic potential energy for deformation is given back to the system in the form of kinetic energy, this type of collision is called elastic collision, or you could also say perfectly elastic collision. Okay. Now, another type of collision is when all of this elastic, sorry, I don't know why I keep saying electrostatic, elastic, when all of this elastic potential energy for deformation is lost by the body in the form of heat or in the form of deformation after the collision, then the collision is said to be perfectly inelastic collision, right? So what happens is that initially the body was moving with some kinetic energy, then collision happens, right? Collision happens, and some of that kinetic energy is used by the body, stored by the body in the form of elastic potential energy of deformation. Now, this happened during collision. Now, after collision, if that stored elastic potential energy of deformation is not given back to the system in the form of kinetic energy, then obviously the kinetic energy of the body is decreasing, right? And let's see that stored elastic potential energy for deformation is sort of used by the system for, like, let's say heat generation or during deformation, right? That type of collision where all of that elastic potential energy for deformation is used up by the system, that type of collision is called completely inelastic collision. Okay, where all of that stored elastic potential energy of the body for deformation is used up. Now, these were the two extreme cases when all of that EPED of the body is sort of like returned back. That is called perfectly elastic collision. When all of that EPED of the body is used up, then it is called perfectly inelastic collision. Now, we have cases where what happens is that initially the body was moving with some kinetic energy, and during collision, some of that kinetic energy is stored in the form of EPED, right? After collision, some of that stored EPED is given back to the system, while the rest is used up or like wasted in the form of heat or deformation, right? That type of collision is called imperfectly elastic, imperfectly inelastic, or imperfectly elastic collision. It could be in either side. Okay, it could be imperfectly elastic or imperfectly inelastic, either will do. Okay, so this was the basic fundamentals of collision and the different types of collision. In the next class, we will study more in detail about what happens during perfectly elastic collision and perfectly inelastic collision. We'll also study about few of the formula that will show up in your exam. Like if they had to give give a question from this topic, then they would give those formula based question. Okay, so stay tuned for the next class.